Hi guys, in this one I'm going to talk to you about a couple different perspectives that you can take on multiplying a vector by a matrix. So take a look here. I'm going to have a 2 by 2 matrix here with the entries 1, 2, 3, and 4. And I'll multiply this by a 2 by 1 vector. So 2 by 1 with the entries 1, for example, and then 1. So one standard way of doing this is to simply do this. First of all, it's going to be a 2 by 1 that is output from the process. And then you do this by doing 1 times 1, which is 1, plus 2 times 1, which is 2. And then on the bottom, you would have 3 times 1, which is 3. And then you would have here 4 times 1, which is 4. This would give us here at the next stage the following, a 2 by 1. Now 1 plus 2 is 3. 3 plus 4 is 7. And that's the output vector. So 1, 1 gets hit with the matrix, and the output is the vector 3, 7. Let's visualize this. So put a coordinate system in here. Now you just have to make sure that you arrange this so that you can visualize 3, 7. So you have to rearrange this, move it around a little bit this way, move this down a little bit more this way, a little bit more. All right, so this shows us enough space now to be able to graph 3, 7. So to do that, take a look. I'm going to take 1, 1, and I'm going to graph it here as the input vector. So that means begin on the origin, go 1 to the right, and then go 1 up this way. Then I can graph 3, 7, which is the output vector. For example, let me do that in gray right here. So that means 3 to the right, and then turn, and then go 7 straight up. 1, 2, 3, 4, 5, 6, and then 7 this way. Remember some basic concepts here, right? That here the green vector is the input vector, and the grayish vector is the output vector. And we're not showing the matrix anywhere in this process. Just the input, the initial stage, and then the output, the final stage. Is there another way to view this? Sure. Take a look. Using the same information, so in other words, the same matrix and vector right there. Take a look at what we can do next. Another way to multiply these is to simply distribute this one over to the 1, 3 column. So it's going to be a 1 times a 2 by 1, which is 1, 3, plus this other one here. So, I should make that, for example, red, so it's differentiated. So this 1 red, and then it's going to be here a 2 by 1, and then 2 comma 4. This view of it is a little bit different because this one shows essentially that the following can be visualized if you look at it very carefully. There's more to be visualized in a certain sense in this context. Again, you still need to have enough space. And now look, grab a vector. Let's see here. I'm going to make this one blue. And this vector will represent this column 1, 3. So it's going to be beginning from 0, 1 to the right, and then 1, 2, and then 3 up this way. Let's do another color here. So let's see. Red. That's going to represent 2, 4. So that means begin from 0, go 2 to the right, and then 1, 2, 3, and then 4 this way. When you write the operation this way, this says take 1, because you're multiplying by 1. So take 1 of 1, 3, and add to it 1 of 2, 4. Vector addition is done by moving, for example, one of the vectors to the tip of the other one this way. And now look carefully. If you go back to the previous picture and you grab the output vector, a copy of it, and you move it over here, do you see how it's still the same output as before? It hasn't changed, okay? The issue here is that it's a bit imperfect because I, freehanded these when I moved them and so on. But if I rearrange this, so move it so it fits a bit better, then you see the alignment is almost perfect. So what is this showing you? In the end, it's showing you that whether you view it as an input, don't show the matrix, and show the output, or you view this operation as basically adding scaled versions of the columns of the matrix, 1 times 1, 3, and then 1 times 2, 4. You get the same output in both cases, except this one shows you the columns of the matrix. This one just shows you, on the other hand, the input vector followed by the output vector. I thought this was kind of interesting, but that's it. So thank you, friends. Please leave a like and subscribe. I'll see you in another video.